Hey everybody, Basil here. On the previous live stream, we started working on converting the Context Bonsai feature of OpenCode into a plugin. So this feature lets the LLM edit its own context, the context being the entire conversation that you've had with the LLM up to that point, including what you said to Claude or Gemini or ChatGPT or whatever model you're using, and then whatever the model said back, as well as any tool calls that happened. That's the context. Context Bonsai lets you take sections of that conversation and cut it out, replace it with a summary and a set of keywords, and then it also lets the LLM retrieve back the context that it cut out if it needs it. So right now it's implemented, sort of integrated into OpenCode. I just forked OpenCode, modified the source code, and now I have a working Context Bonsai feature. Yesterday we started working on taking the let's see, I did a before the live stream, I started a project that tried to figure out the minimal set of changes to OpenCode that's needed to support the plugin. And then at the end of the episode, it was going to take a while to convert that document that outlines the changes into an actionable implementation plan that an LLM can follow. And I expected to just let it chew on that plan for a little bit and then come back and start today with the actual implementation plan. But I ran into something pretty interesting. So what I discovered is that in chatting with the LLM, trying to make this implementation plan, we started talking about a few things that we already covered when I ran the research project. When I did the research project, a big part of it was around update atomicity, so that when you modify the conversation, because several parts of the conversation are involved, and you have to sort of modify attributes on many messages within that conversation, that modification should be atomic so that you don't end up in a situation where it will read the conversation, figure out what updates it needs to make, and then apply those updates to the conversation. There may be some edit that happens in between when it originally read it and when it applies the modifications. So to make sure that that's a safe operation that doesn't have unexpected side effects or bugs, it's important to have atomicity. So a big part of the original research project into how to do this, I chatted with the LLM about how to make that an atomic operation. So now when it's coming time to actually build the implementation plan and it's looking into it, I've jumped to the latest head of the development branch of OpenCode. And a lot has happened since I originally created the Context Bonsai feature, which I started working on it, I think, last December. And now it's middle of February. In that time, since I started working on it, they have changed the entire storage backend. It used to be stored, the session, the conversation, the context was stored as a JSON file. Now they have a database backend, which actually should make this much more robust. I'm excited about that. But at the end of the previous stream, when I started working with the LLM to get it to build this plan, that's when it discovered this difference. And I had it discovered that there is this database transaction mechanism that could be used, but our plan specifies various direct updates to the storage engine. So digging into that, discovered we actually need to make some modifications. So I paused there so that we could come back and go through that today, because part of why I'm doing this live stream is to sort of show people this planning process of this is part of how you do LLM coding or vibe coding, is you have to sort of understand what's happening under the covers and make smart decisions about things and not just blindly let the LLM do things, because all kinds of interesting things can happen, things that hopefully I'll be able to demonstrate in these live streams because even though I'm tracking it and trying to understand everything that's going on, there are still things that slip through sometimes that eventually get caught later. So we'll probably run into some of those things. So yeah, let's get started. So let's see. I need to get oriented to what's happening here because I left off yesterday and haven't looked back at this again. Let me see, what was my last message? Before fixing line numbers, do a validation that runs checks. Do a loop, validation loop. Everything needs to be updated to work with it. Oh yeah, okay. So I told it that implementation plan that we were building and the actual project files, all the whole thing, everything that we're working on needs to be updated to work with the database backed storage. And then even after it takes care of that one part of it, I'm also going to have it go through and review the changes that happened since the feature was originally developed and now what's happened to the underlying code in OpenCode, and see if there's anything else that needs to be addressed within this plan. Okay, so yesterday we went over part of the planning process. I have a document that I asked the LLM to follow about how to actually plan the changes. And in that document, it describes a review process where it creates a plan, then it launches a sub-agent with a fresh new context that doesn't know anything about the project, and it gives it the plan and asks it if there's any ambiguities in the plan, or if there's any incongruities between what the plan says and what the code underneath actually supports, and even if there's any incongruities within the plan itself. Does the plan agree with itself? Does the plan agree with the code that it's going to be modifying? Does the plan agree with the overall intention of the project? So that's where we are. We're in the middle of that process where it's developing the plan and then it's getting that plan validated. And this report is the most recent validation run that it did. So it ran the validation. It asked a specific question about the ID format. One of the questions I asked was whether the message IDs changed at all. Let me see if I still have... Yeah. So here's an example of the modified OpenCode. And in all of these messages, there's a little message ID here that I've made visible in the OpenCode output. So those are the message IDs as they existed back on the old storage engine. Now that it's in the database, maybe that message ID has changed. I asked the LLM to look into that. Where were we? Which one? This one. Okay, so it says ordering assumption mismatch. Docs currently apply chronological orders guaranteed by message ID format. Yes, those message IDs are created out of a timestamp along with additional metadata. So the messages are guaranteed to be in chronological, or the message IDs are in chronological order. They're the order that the messages occurred in if you sort them. In the current DB code, message ordering is from time created, not ID. Okay, that's probably fine as long as the ID still is generated from the time created. If these two share the same millisecond timestamp, ordering can be non-deterministic. Oh, if two messages share the same timestamp, they can be non-deterministic. Sure, unless a tiebreaker is added. Sure, that is correct. Any between anchor and range end by array position logic has a theoretical edge case risk. Yes, it is theoretical, but it's hard to imagine there will be two messages that are within the same millisecond because of the nature of these LLM tools. I guess now the tools can launch multiple tool calls simultaneously, so it is possible that tool results will come back and have the same millisecond timestamp. It's going to be almost impossible for a user to submit two messages one after the other with the same timestamp, especially since messages end up getting queued and processed one at a time. And it's definitely impossible right now for LLM messages to have the same millisecond timestamp. The LLM, even just the latency between here and the inference provider and back again is more than a millisecond. So until there are like parallel inference calls that come back at the same time, or there's weird things happening, this is not much of a risk, but I'm still going to ask it to look into what options that we have for avoiding the risk, just to see if there's something simple we can do that will avoid this. If it turns out to be really complicated to strictly prohibit this non-deterministic ordering, then I'm just going to call it out in the code itself. I'll have comments in there, and it will say that, you know, this ordering could be non-deterministic if two messages are in the same millisecond. Session update message is not transactional. The existing session update message, sure. That's one of the things we were trying to fix, because so one of the things that happened was there was an initial the initial research project to convert it to a plugin was one set of documents, and then I distilled that set of documents into something much smaller to present to the upstream maintainers in OpenCode to see if they wanted to provide any feedback. That distilled document is what I initially started working from, because I forgot that there was so much missing from that distilled document that I was going to need. So that distilled document didn't have specific stuff about the transactional nature that's needed for updating the messages. I didn't have the atomicity guarantee in there, but the original project documents did. So that's why the current plan, it's finding that it doesn't have the correct like transaction semantics here, or the atomic semantics here. But it does say the story is directionally correct because it proposes a new transactional helper. Yes. So now story 3 is the thing about updating the messages. And that's the thing that needs the atomic updates. So because it is now using the database layer, there is going to be a transactional semantic. And it's using this database.use instead of database.transaction. I'm going to ask the LLM what is the deeper impact of that. Why would one choose one over the other? And we'll see what comes out of that. This is also, we're not just catching mistakes, but we are deepening our understanding of the product itself. That's another thing. There's an interesting article that came out recently. Let's see if I can find it. Where some publisher or some company identified that technical debt isn't so much the biggest problem when you're doing LLM coding or vibe coding. A bigger problem is cognitive debt, where you just sort of lose connection with what the code is actually doing. Let's go see if I can find that. Oh yeah, Simon Willison talked about it. That's how I found it originally. And here's the article. The term technical debt is often used to refer to the accumulation of design of implementation choices that later make software harder and more costly to understand, modify, or extend over time. Technical debt, well understood term. Technical debt nicely captures that human understanding also matters, but the words technical debt conjure up the notion that the accrued debt is a property of the code and effort needs to be spent on removing debt from the code. Cognitive debt a term gaining traction recently, instead communicates that the notion that the debt is compounded from going fast lives in the brains of developers and affects their lived experiences and abilities to go fast and make changes. Even if AI agents produce code that could be easy to understand, the humans involved may have simply lost the plot and may not understand what the program is supposed to do, how their intentions were implemented, or how to possibly change it. Cognitive debt, very important. This definitely hits home with my own experience and is something that I've actively fought for from the very beginning. Like, I noticed that was a thing that happened early on. Is my very first project was this actually like a sub-agent orchestration system. I was working on it about 10 months ago or something, before before Agents Act really supported sub-agents. I created my own sub-agent thing. And what I found was that I was able to go really fast and produce a lot of things, but then it started having behaviors that I didn't want, or I didn't intend for it to have. And I started digging into it to try to fix those behaviors, and I found that there was so much in there that had changed that I didn't, first of all, I didn't understand. Like, I had to spend a lot of time reading the code to understand what it was doing and why it was doing that. But because I didn't understand it, I wasn't really able to fix it the way I wanted to fix it. It wasn't such an easy fix. I couldn't even explain to the LLM exactly what was wrong and exactly what I needed, because I would explain something to the LLM and it would say something back that just sort of didn't make sense to me. It didn't track with my own mental model of what I had created. So yeah, ever since then, I've been on this active, I've been actively fighting against cognitive debt. I'm glad that someone sort of named it, identified it, because that's something that we do need to pay attention to. So reading these reports, digging into the things that it says as you go through, not just letting it do it and looking at everything at the end, is pretty important. So we're going to look into this database.use, database.transaction. We're going to understand that on a better level. Low stale context in story 1. Okay, it references storage.read. Yep, we probably aren't going to use storage.read at all anymore. That was for the JSON storage engine. Messages now come from DB paths. Yep. Direct answer to your ID format question. They are still the same format pattern. Yep. DB retrieval order is based on time created, not ID sort. If you want, I'll apply the doc fixes for the 3 items without touching line number cleanup. Okay, so yeah. So yeah, first, I want to cover some details. I need to understand them better. The first one, oh yeah. Okay, let me think about this. The ordering. Okay. So that ordering might happen in the message range selection. After I ask it the couple questions and it starts chewing on things, I'll redo a quick demo for people who have not seen the first video. I'll demonstrate what all of this is talking about, what the Context Bonsai feature is, why we're talking about message ordering and storage backends and all of that. Um, whoa. Okay, and second, I want to understand the difference between database.use and database.translation. What I'll do these live in, and what do each of them do? Okay. All right, quick demo. Let's quit this and relaunch OpenCode without continue. Great. This is using the Minimax LLM model. Let's see. So this Context Bonsai feature lets the LLM edit its own context. It can remove stuff out and replace it with a summary. So to test this, I'm going to tell it a secret word. And I need the LLM to not really mention the secret word unless I specifically ask what it is. And I hope as I show the feature, it'll be clear why I need it to do that. Okay, so there's its initial instructions. All right. And also, when it does this context bonsai thing, when it removes context out of the conversation, it gets a summary, and it replaces that part of the conversation with a summary and with some keywords. And when it creates that summary, the way it does it is it takes those messages that I've asked it to summarize, and it sends it to the LLM provider, just that portion, not the full conversation. And it says, give me a summary of this conversation. And this conversation is just whatever range of messages that I'm asking it to summarize. And then the LLM provides back a summary, and that gets filled in instead of the actual conversation that happened. So in the same message that I'm telling it the secret word, I have to tell it, don't include the secret word in the summary. Okay, it thought the secret word, but that's fine. In OpenCode, the thinking output is not fed back to the model. The model does not see the thinking results. Got it, understand. I won't mention the secret word. Good, it did it. If you see yesterday's stream, we tried the same experiment, but it kept saying, okay, I'm not going to say lepton, or I chose a different word last time. So great. Now the only message that the LLM sees that has the secret word is this one right here that says the secret word also should not be mentioned in the summary. The secret word is lepton. This is the message ID here. And I can tell it to summarize, and I can give it the exact message ID, or I can do it like this. Just compact any message containing the secret word. Okay. So then the first step that the LLM has to do is turn on the message IDs. So right now, these message IDs that are associated with the messages, the LLM doesn't see those. It needs to turn them on and then it can see them. So that's what it did here. It ran the compact tool without specifying any ranges. And when it does that, that's what turns on message IDs. So it did that. Message IDs, the tool outputs this. It says the message IDs are now visible in the conversation, and it says don't mimic or generate your own IDs. If you don't say that, a lot of models will just mimic the message IDs, and that's why they're off in the first place. With normal conversation, you don't want those message IDs present, because if they are, the LLM sees that pattern, and it will just mimic that pattern in its own responses, and that's confusing to the person using it, and it's also confusing to the LLM because it sees those message IDs later on because they're not part of the harness mechanism anymore. They're embedded in the conversation. So here's it thinking about the various message IDs, and it figured out which message ID has the secret word, and then it compacted a range that just includes the one message. And this right here is what the tool has output. It said you archived one message that was 22 tokens across one range. And if you want to restore that content, retrieve this message ID. So there's the compact tool, which you just saw. There's also the retrieve tool. The retrieve tool lets it's specify a message ID and it gets back whatever was hidden in the first place. And here's the summary that came back from the LLM. The summary says the user revealed the secret word and instructed me not to mention it or include it in any summaries. This established the constraint for the Context Bonsai demonstration. There's the index terms. The index terms are just another mechanism to help the LLM know if there's something in those hidden messages that it needs to get back later. So I'll demonstrate that now. First, now that it has compacted the message that had the secret word and replaced it with that summary, it shouldn't know what it is. And yeah, it says it doesn't know what the secret word is. The summary references a secret word, but doesn't include what it is. Okay, so it doesn't know the secret word, but now I can tell it to retrieve the secret word, but I'm not going to specifically say retrieve. I'm just going to say do whatever you can to figure it out. And it understood that it can use the retrieve tool to get that message back and find out what the secret word is. So here's the output from the retrieve tool. It called retrieve, it gave it the message ID, and then the tool result is this. Retrieved content from that message ID. It shows the message ID and user message. The secret word also should not be included in the summary. The secret word is left on. That's exactly the message that I sent it. And then it says, okay, the archived message reveals the secret word is left on. That's how that works. And you can also it doesn't have to be one message. It can be a range of messages. So I can have it do this again. So the atomicity and the message ordering that the plan was referencing it, this is why it matters. When you specify a range, that range relies on an order of messages. If the ordering of the messages isn't correct, then it might like pick one side or the other side of the boundary of that range. Okay, this time it didn't follow the instructions not to include the secret word in the summary. So this is why originally in the message that I asked it to compact, I very explicitly said, don't include this in the summary. This time, because that was like one small part in a broader range of messages, it didn't catch that instruction and treat it as something important. So it included that in the summary anyway and in the keywords, so it still knows. If I ask it if it knows, it probably knows. Yep, yep, it definitely knows. It thought about it right there. What's happening? It's considering lying. Yeah, okay, there we go. Yeah. Um, so I'm gonna try to have it do another layer of compaction. And this time we're having more conversation about not including it in the summary. And I'm going to include these messages about not including it in the summary in that compact range. And hopefully the model catches on this time that it shouldn't say that word. Okay. All right, let's see what happens now. It turned on the message IDs. Now it can identify which messages have the word. Nope, didn't work. Okay. Well, this model isn't smart enough to handle this, I guess. Let's see if I can change to Claude. Do Zen there. Claude Opus 4.6. Let's go for the most recent. Oh, that is almost certainly a bug in my feature. So Anthropic has kind of strict requirements for what message parts are included in messages and kind of the order that they happen in. This used to work with Claude, but apparently doesn't now. So that's something I'm going to have to dig into at some point of what's happening there. And the way to deal with that is Anthropic publishes the APIs for how messages work. They're not, there's still some ambiguity in those documents, but it's a good reference point for the LLM to kind of work through issues like this. But that'll be a whole different video, a whole different time, probably after I complete the transition to converting this to a plugin. That's interesting. Okay, then let's try GPT. Oh, models. Z. Oh. What is it called? Zen. GPT. Let's go 5. Okay. Avoiding tool-generated summaries for those messages and using a redacted manual summary. Or no. That wouldn't work. So what's funny is sometimes the LLM models understand how the LLM chat harnesses work, but sometimes they forget that understanding the way the model works is important, and it kind of pretends like it's a human, or that it can do things that it can't actually do. I found that interesting while working on this feature. It's like that's not how this works. That's let me just see. Um, um, Now, I'm going to give it an instruction, and I'm including the secret word in the instruction that I'm giving it so that this message is included in the total range, and the instruction that it shouldn't say the thing is in this same message. Okay, let's see if this works. So this whole back and forth is it's fun to play with, but it's not necessary for the feature. Like there's no situation. Oh, there actually is a situation where you specifically do not want something leaking from the old context. That's actually one of the reasons I wanted this feature in the first place. So one of the things that happens when you're working with an LLM is something enters the context that sort of throws the entire session into a less productive state. Like sometimes it'll read a piece of information that is incorrect, but it keeps treating it as correct. Even if you say, no, that thing you read was wrong, the correct thing is this. Because that context is there, is because that is in the context at all, the LLM sees it and it still affects its future output. And that can sort of cause an entire conversation to go south. um, and it's hard to recover from. You basically just have to start over completely fresh right now. One of the reasons this feature exists is so that when that happens, you can just cut that out of the conversation, pretend like it never happened. Um, let's see. I might update this in the future so that in addition to asking for a summary, there's a separate set of instructions that guide it on what to include or not include in the summary. Right now, that doesn't exist. All it has is the actual conversation that it summarizes. Um, you're right to require sanitized compaction with the current compaction tool summaries. Did it even try to do it? Silent compaction. Dude, no. Silent compaction doesn't do what you think it does. So that's a little bit of a problem. One of the features that I'm not carrying over to the plugin are these modes of like verbose, silent, or normal, where it can ask the user, hey, I think this part of the conversation should be summarized or compacted. Do you want me to compact it? And then the user can say, yes, compact that, or no, don't compact it. And I put that in there because I wasn't confident about whether the LLM would just randomly start compacting parts of the conversation that you don't want compacted. That doesn't actually happen. It's actually really hard to spontaneously trigger compaction. That's another thing that I'm working on in the future. I want it to spontaneously compact more than it currently does. So the silent mode is just not needed anymore, or the silent mode should be the normal mode, but the silent mode is about what the user sees, not what the LLM sees. So it got confused about that. So that means that the tool cards that explain how that work need to be clearer about what silent means. Redacted pipeline, enable a redaction filter. There is no redaction filter, dude. Manual path. I list the message IDs that contain the secret word and provide a redacted human written summary. Nope, you can't. You can't do any of those. Okay. Okay. So I've told it just do it normally. We're trusting that the LLM will understand this time since I've switched to a different LLM model. Let's see if it actually does the compaction. Oh, I forgot that I want to pull up the YouTube chats and see if there's any live chat happening. Oops. Boy, ChatGPT is super thinky. There we go. Okay, that's what I thought. No chat yet. Hey, finally, it's starting to do stuff. Hmm. Okay, confirm the two IDs to compact. Do. You should not be asking me this, guy. So, I had this problem early on when working with this tool, and I haven't seen it since I added a fix. The fix is in the tool cards. It says you shouldn't be asking the user what to compact. You should just do the compaction. This is not working with ChatGPT 5, apparently. Hmm. Holy moly, guy. You are thinking way too hard about this. Darn. Nope. Okay, finally. Return to JSON compaction for the range starting at that, noting an earlier compaction inadvertently included the secret word summary. Okay. This time, there's no leaking in the summary or the index terms, but I don't know if the range it selected was correct. That's not showing me. Okay, here it is. It only compacted one message, which has to be wrong. There was at least the summary that had the secret word and my instruction that said compact it but don't say lepton. And that's really surprising. So I have found usually the frontier models are way better at it usually than the open models, or like I've been using a variety of models, and usually the ones that score generally lower on benchmarks are also generally worse at doing this than the frontier models. But this is kind of surprising that we're struggling so much here with GPT-5. Yeah, you already archived that. What? Guy, come on. I attempted to, but both are already archived. Um, uh, First of all, let's ask it why it knows it. Later propagated by auto-generated compaction. Okay. This has been an interesting side distraction. I didn't expect this to take such a detour down this route. Is that the one that it attempted to compact? Nope. It's already. I saw it before compaction when the message was still visible. That actually is exactly what I was talking about before when the LLMs don't understand how LLMs work. It it can't remember what it sees. Like, it doesn't have memory. All it has is the actual conversation that we're presenting to it. If we're presenting to it a conversation that doesn't have those messages, it doesn't have memory of those messages. Um, um, what it, what it could know is that we talked about the message idea containing the secret word outside of what was compacted, and that's how it could know. Um, um, So I think I might need to consider adding some sort of visualization to OpenCode so that I can tell exactly which message parts are visible to the LLM and not visible to the LLM because it just has the chat history still there. And so it's hard to understand exactly what the LLM can see. Um, okay. Oh man, the thinking is kind of annoying. It definitely still knows the word. It's thinking about it here. Okay. Let's see if this works. This will be pretty interesting if it, either way, if it works, then great. That means the feature itself is working, and I need to work with Chat GPT more to figure out um, how to fix its understanding of what's happening. If it doesn't work, that means there's a bug in the feature, which is interesting because it does not show up in when I work with other models. This single compaction failed. The earliest message ID is already the anchor of an archived range. Oh, yeah. So there, yeah, there's in the context bonsai tools, there's sort of things to prevent it from doing silly things like archiving ranges that overlap with each other, or archiving or ranges that sort of contain other ranges. And I think that's what it's running into here. I'm going to save this session so I can look at it closer later. I want to save it as JSON. Let's see. How do you, let me see. Export, that's how you do it. Okay. Oops. Let's put it preview parent directory. Okay, that is not what I want. Oops. To do logs version compaction mode disable session list. Okay, that's what I wanted. List. This copy. Now yeah, export, and can I get help for that? Oh, oh, that's what's happening. Yep. Okay. Go back to export, and this needs not that. Still didn't work, but actually now we're getting better messages. Okay, I think maybe the format JSON is also not necessary. There we go. Okay. Yep, that's the one. Okay, now it should be right. Yes. Yep, and that has left on all over the place. Good. Okay. All right. Anyway, that is what the feature looks like. It can compact sections of the conversation and replace it with a summary. It leaves index terms behind. And then that means that, for one, the raw conversation is no longer visible to the LLM temporarily unless it decides to retrieve that conversation back. And it also usually means that you're saving tokens. So the context has a maximum size. And even before the maximum size, there's like a maximum useful size when the LLM is actually productive. So allowing the LLM to take entire chunks of the conversation and replace it with a smaller summary lets you not hit the context size limits. But even more important than that is it keeps the conversation focused. So if it is trying to accomplish a task and it went on some debugging route to try and figure something out, and then it figured it out and it's able to continue its task, that whole debugging session is detrimental to future output of the LLM. So it will serve the it it's better for productivity if it can just cut out that whole process and just keep whatever it learned, which is much smaller, and continue on the process. That's the whole idea behind this Context Bonsai feature, at least the beginning of it. Context Bonsai is going to be more about sort of a continual pruning and cultivating of the concept in more ways than just what I've shown. But this is, I think, the most important baseline feature to get working, because this sort of proves out the concept. And then once that's proven out, there will probably be things like, I want to load certain chunks of context in ways that work potentially better, maybe not, as loading like a file. Like we typically load markdown files, or we load a code file into the context, and that helps the LLM accomplish tasks. There may be other ways to add context into the conversation that helps the LLM perform better. Like it might be better, instead of simply reading that here's the things that here's a bug that's happening, here's the things I've tried, figure out what to do next. Instead of just reading that here's the things I've tried, maybe it's better for it to see an actual process of a couple tool calls and modifications and another tool call, and now it's fixed. That might help the LLM perform better later than simply reading a document that said, here's what happened. I don't know. It'll be interesting to see. And I've had other ideas for how to do this Context Bonsai stuff, but I haven't written them all down yet. I really should start doing that, but I've mostly been focused on this stuff. Okay, back to where we were, this plan of converting it to a plugin. There were a couple of questions I had about its findings in the current plan. One of them was about the non-deterministic ordering of messages if two messages have the same millisecond timestamp. And the other one was about the two different database methods that are available and what they do differently. Okay, so captured to-dos, good. Update the docs, yep, I'm gonna want that updated. Update story one context refs, yep. Optional note from plugin cast limitation, okay. I don't remember talking about that. I'll go back and look at the notes again. Non-deterministic ordering, where it matters. Okay, the message IDs are still monotonic. Good. But message retrieval is ordered by time created, not by ID. Oh. Okay. Got it. No, I don't got it. Message retrieval is ordered by time created. Okay, so the new database layer, I guess, doesn't care about the message ID ordering, it cares about the time created ordering. But then wouldn't that be a deeper problem? That's interesting. So, um, I think this is already part of the database system, the new storage backend for the messages, that when it gets the messages to send to the LLM, when it pulls them out, it orders them by time created. Even without my feature having anything to do with this, I think that means that if there were two messages that had the same millisecond timestamp, they could be in different order. Again, I think this is not a practical problem at this point, but I am interested if there's a simple way to address it, then I want to address it. But if this is part of OpenCode already, just baked into there, and it's not part of my own plugin, I don't really want to test it. I'm looking for the most minimal set of changes to OpenCode that I can make to have my plugin work. I am not trying to fix existing issues in OpenCode. That's a scope creep. Oh, it's talking about filter compacted. That is my plugin. Query sorts by time created. Both get same time created. Okay, I have to clarify. Is this talking about in our own plan for the plugin? Are we ordering by time created? Like, okay, so originally this worked on the JSON storage. I had it generate the plan to update to the database version. When it did that, did it decide to use this time created thing? Or is just message retrieval in general in OpenCode already ordered by time created? That's a question that I need. Okay, now the database use versus transaction both live in that file. That'll be fun to look at. Database use, if already inside of a database context, reuses the tx/db handle. If not, runs callback directly against the database client. No explicit begin commit. Good for single operations. Database transaction. Okay, so we want a transaction. Yes, and it agrees. Okay. What did it call it? Time retrieved? Time created, right? Yeah. Someday I'm gonna try to add Vim keyboard bindings to OpenCode. Um, and that will be an interesting project. Um, okay. Okay. So that's already baked into OpenCode, it looks like, but I'm wondering about this filter compacted thing. I thought that was just added by my plugin, but maybe OpenCode's own auto compaction also did something similar. Um, oh, I should have just opened that file. Message v2.filter compacted in that. That's the one called from the main loop. Um, trims the streamed history to the most recent relevant segments after compaction. Oh, okay. So it, I guess, already did when the normal open code auto compaction happens. I guess it keeps the whole session there, but moves the compaction point forward so that when it sends messages to the LLM, just the old messages aren't sent, but they're retained. I didn't know that, or I at least didn't internalize it if I saw it before. That's pretty interesting. That could open up some interesting use cases of being able to find old historical elements in the conversation and get information out of that, kind of similar to what my features add. Okay. Um, okay. So yeah, I'm not worried about the message ordering thing and the timestamp. Um, that's something OpenCode could deal with if they ever want to. Uh, and the database transaction thing is correct, so that should get updated. Um, but in the docs, it should call out that this is a known. I don't know if I'd call it bug, but this is a known condition of the open source of the open code project, and it's not something that's in scope for dealing with in our own project. That kind of thing has to be called out in planning docs because of the way I do LLM development. I have a developer uh, like run through the implementation plan and implement all of the changes, and then that gets submitted to a reviewer, and the reviewer catches issues. It needs to understand that this is not an issue that we're going to deal with. It should just ignore it. Like, if it might see it and understand that it's a problem, but it's not for us to deal with. So that does need to be called out in the docs. Um, All right, and it offered so this implementation plan is broken down into one epic, and the epic is composed of 5 different stories, and each story is like one change that needs to be made to OpenCode. There's 5 different changes that need to be made. So in addition to putting it in the overall project document about what the project is in general, it needs to be in the actual story files. The story files are definitely going to be used by the developer and the reviewer. Ideally, the reviewer will also see the project files, but it's not bad to have it reiterated in both places. Okay. Um, um, there. Okay, so it's updating the rest of the project docs. Or updating the rest of the items in the project docs. Yep, converting from the JSON storage to the new transactional database storage. Oh, nice. It's spontaneously doing the validation loop. Great. So we talked about this in the previous stream, but I'll say it again because not everybody's going to watch both of these. I'll be surprised if anyone watches either of them, but just in case, there's a document that I have called Planning Guidance that has the LLM generate plans the way I like to work with them, but it also tells it to validate the plans that it creates. One of the big recurring issues with LLMs, when it creates a document, it assumes too much knowledge by the person consuming the document. The LLM knows and understands things itself, and when it creates the document, it creates it with the assumption that whoever is reading it also understands what it understands. But then you hand that off to another LLM or a human, and there's just entire gaps. Like, it just doesn't make sense. There's things missing from there. So I have this LLM run a validation using a subagent with a fresh context that doesn't know anything about the project. It can do research and it can read the project docs and read the code and figure things out. But that subagent, the whole purpose of it is to fill in the gaps or to identify the gaps in that document. And it also identifies places where the document doesn't agree with itself or with the code that it's referencing. Okay, it applied the remaining agreed items. Yep. Okay. Missing details check, no blocking or missing details. Ambiguity check, no unresolved high impact ambiguity. A little, nothing high impact, but 2 low impact ambiguities remain. From plugin cast follow-up scope. Docs now correctly say explicit mapping improves clarity, but there's still no explicit decision on whether to keep as unknown as plugin context as is or schedule a separate hardening task. Okay, I should ask it more information about that. Story 3, write primitive detail. The docs specify a transaction plus read plus validation, but don't pin the exact internal write helper signature name. For example, whether the new handler wraps session.update message internals or does direct upsert logic. Implementation guidance is still sufficient. Um, okay. Human implementer with repo can infer the right path. The docs already pinned transaction boundary, read primitive validation, and single. That's why that's weaker for LLM only execution. There are multiple plausible implementations. Okay. Then I'm surprised it considered this low impact. One of the things in the planning guidance is that if there are multiple plausible implementations, that needs to be settled out. That's the whole point of doing this validation loop. Um, okay. So another part of the planning guidance is it tells the LLM do your own research, figure it out for yourself. Don't ask me a million questions about how to do every single thing. Um, and usually it does a decent job, an acceptable job, and I'm happy with its results. But what's not sustainable is if it asks me every single time, it can do something in a variety of ways. 95% of those are really obvious. Like, it should be freaking embarrassed that it even asks the question in the first place. So part of that planning document tries to get it to figure it out for itself. Don't ask me. So, yeah. Apparently, I should also add some nudges in there to help it understand that this kind of the decisions should be made during planning. Don't rely on the implementer to make decisions when there are multiple plausible implementation strategies. Because now is when it's the easiest to fix and address. Because once that decision gets made in code and then other code builds off of that, it can have sort of a chain effect where it kind of invalidates a lot of work and a whole lot of time is wasted. I like to figure out this stuff during the planning phase, and try and identify issues now, because then we sort of settle most of these things, and then I can just launch the development process, and I have an entirely separate loop for running the development process and getting it to go through all of the epics and the stories that this thing creates, and having it like validate it and go through the whole process. And that pretty much runs autonomously for hours. It'll just go implement the entire plan. Usually it doesn't have to ask me anything because we've already settled it in the planning stage. And then I can come and review it. And it's usually pretty decent at that point. But in order for it to be decent, I really have to get this first planning stage correct. Great, it finalized the decision. Great. Now, this was ChatGPT. ChatGPT has updated the project documents and the implementation plan. Now I'm going to go to Claude, and I'm going to have Claude try to identify issues. Actually, come to think of it, this already used Claude. Oh no, yeah, I think so. Yeah, this is not OpenCode. This is Codex, which means it is using ChatGPT, I believe. Yep, okay. So ChatGPT, I was a little surprised to find that it does not have native subagent support. I think that actually recently changed. I saw a news item pop up, but I didn't look at it. But because it doesn't have subagent support, here's the process that we go through to have a subagent in Codex. Oh, I didn't mean ChatGPT doesn't have subagent support. I meant Codex. The CLI doesn't have subagent support. So here's the process that it goes through. It creates a temp file. It puts the prompt, the instructions to the subagent in that temp file. And then it runs Claude. And -p is the argument for here's your prompt. It cats the temp file as that prompt. And then this output format argument causes Claude to not just launch the interactive session, but instead process the prompt and return back text. So that's what this command is doing. So actually, this is already doing a 2 different model validation, which is great. I think I'm ready now to move forward. Let me look exactly on the prompts that it's giving. Okay, that was specifically looking at story 3. This is a pretty narrow thing to consider. Earlier, it didn't ask about one specific story, but it did ask for the whole cross story thing. Okay, and here's what it asked. You are a planning consistency subagent. And there's the epic, there's the story files. Oh, there's actually 6, not 5, 6 story files. Find contradictions, dependency mismatches, incompatible type assumptions, acceptance criteria conflicts, sequencing issues, and places where one story's plan invalidates another. Okay. That's good. Except it's missing comparing these implementation plans to the actual project files. So this is the implementation plans are low level of exactly what is changing where, but there's no sort of overall. There's some in the epic, but there's a lot more in the project document about what Context Bonsai is and what we're doing. We're adapting this to be a plugin, and we're looking for what OpenCode changes specifically are needed. So I am going to launch Claude. I'm going to give it those project documents. I'm going to explain it a little more of what's happening here, and then I'm going to ask it to review these implementation plans. Let's close out some windows here. Tabs. Okay. Okay, and I need the path to Okay. And I also want the paths here. Oh, that's fine. I can just include the dashes. It doesn't matter. I was going to filter out the columns there that have the formatting, but it's fine. This is an LLM. It can figure it out. So back to Claude. Okay, it's read them all. Let's make sure. Yeah, it requires 5 changes. The main proposal is a plugin. Yep. Okay. Um, so I'm asking it to look, for the what I just talked about, the overall that the implementation adheres to the actual project plans. But I also want it to take a look at whether this matches the current state of the OpenCode project, because it's been a couple months since the original set of OpenCode changes, and the proposal was written back on that original set of changes and how they differed from the open code as it existed at that time. Okay. This is going to take a while. While that's going, I'm going to make more coffee. I'm going to turn off the camera for now. Oh, I wish I had a little way to put up a I'll be back message. Mm, sure. To do camera. Top right. Yeah. And microphone mute. And I'm back. Ooh, it had already finished. Great. Okay, found some stuff. Nice. Whoops. All 6 stories faithfully map to their corresponding changes in upstream proposal and project proposal. The scope, approach, file targets, and acceptance criteria are consistent. No story introduces scope creep or deviations from the stated design. Alignment is good. Issue 1, line numbers, reference current branch. Oh yeah, that's something the other one called out and said it was going to update, and we forgot to get back to it. Okay, fine. Severity medium will cause confusion. Agreed. Either update the things, sure. Plugin.list call site count is wrong. Fine, that's fine. Oh, affects backwards compat confidence. The story and both proposals claim 5 call sites for plugin.list. Actual state on dev. Okay, those 2 are not fine. There are 6 call sites, not 5. Okay. Story 3, database use versus transaction distinction. Plan is correct, just worth noting. The existing session.update message uses database.use. Story 3 correctly specifies database.transaction for the new update message atomic helper. Yep. The plan is right here. This is just a note that the 2 helpers use different DB primitives, and the implementer should understand why. Okay. SDK regeneration mechanism needs clarification. Does it? The plan works, but the mechanism is incorrect. Story 1 says run SDK regeneration script from the repo root. The build script works by running bundev generate to produce the stuff using add hey API open ITS to generate TypeScript types. Sure. This means metadata field propagates the stuff. The story is correct that running the script is sufficient, but the implementer should know this is a 2-hop generation, not a direct ZOD to TypeScript step. Sure, that's fine. Story 6 model type compatibility, severity low. The story flags this, just confirming. The story correctly notes the need to verify structural compatibility between the runtime provider.model and the SDK model type. On dev, provider.getLanguage takes provider.model, the internal type, as the input. The transform hook would pass this object directly to the plugins with the SDK model. The story's acceptance criteria explicitly verifies structural compatibility is the right guard. These types may diverge if upstream adds fields to one, but not the other. I want to understand that one more. We'll look into that. No substantive upstream code changes invalidates the plans. Severity none. This is a positive finding. Despite the line number drift, all the structural claims in the plans hold true against dev. Okay. Let's go through. First of all, how's the context doing? Okay. Let's have it write this. Yeah. Since the context is already about halfway filled up here, I want to make sure we capture this output before we move forward so that we don't lose track of it. Which is why I'm having it write to a file. I'm surprised it's taking this long. It's only output 32 tokens so far and has thought there for 50 seconds. Here we go. Okay, so the thing I wanted to learn more about was issue 4. Nope. Issue 5. Okay, it's going to show me the type definitions side by side, but that's good to understand. But more, I want to understand what it's talking about with the model and the SDK. Is that what it said? Here. Provider.model and the SDK model. Okay, so there's two things called model. One is on provider and one comes from the SDK. On dev, provider.getLanguage takes the provider.model as input. Okay. The transform hook would pass this directly to plugins typed with SDK model. Ah, got it. Got it. So plugins receive an SDK model. Is it doing a cast? Oh, the other thing mentioned a cast. I wonder if that's what this was talking about too. Okay. Featured versions. Yeah. If upstream adds a field to provider.model, but the SDK regeneration lags. Oh, it's for the regeneration. Is that just a standard concern with regeneration, code generation? Um, so this SDK regeneration, what it's talking about is a lot of projects generate SDKs from some sort of definition. Um, there's one that Amazon uses called Smithy. There's one that has open in the name. I can't remember what it's called, but some way to define an API, and then that is used to generate SDKs. So that way you can make TypeScript SDK, a Python SDK, a Ruby SDK, whatever kind of language you want to be able to use your API. The SDK can use this like model definition so that it has the compatibility across languages to use your API. That's what this is talking about, I think. Um, Standard design concern. The pipeline here is clean. Okay. I don't care about that. That's just normal with this kind of setup. There's nothing unusual about the setup, and TSC catches it if they do diverge. Oh, TSC catches it, and there's already like Git hooks that prevent you from doing stuff if it prevents you from, I don't know, committing or pushing or whatever the hook is if TSC catches something. So this is not really an issue at all. Um, Um, yeah, so now I do want the issues that it found, I want them all addressed. I'm asking it to have a subagent do all of that work, and then it's going to validate it. Because at this point, context is halfway full. I have found that right around halfway is when performance starts degrading. The closer it gets to all the way full, the worse it's going to get from here. So I want to preserve this original context as much as I can. So it's going to launch subagents. The subagent is going to do all the tool calls and all of the editing and stuff. And then once it's done, this agent, the primary agent, can read the output and see if things are the way it expected, because this primary agent has the context and understanding of what it means for these changes. And remember what I said when the models produce a document for other things to consume, it kind of wait to when a model produces output for other things to consume, it assumes knowledge of the consumer that consumer might not have. That knowledge is currently in this session. So this session is the best one to judge whether or not that model did the right things. Okay, there it goes. All changes look correct. Great. Okay. Whoa, oops. Limit all changes. Boop. And I think I'm going to end here. And tomorrow's live stream is going to be actually running the development process. Committed 8 files. Okay, now double check here. Is there anything uncommitted? Come on, guy. Oh, yeah, and it even called those out. Historical documents with pre. Okay. Yeah, I'll just. Great. Okay, so I'll end the stream here. The next stream is going to be taking this implementation plan and kicking off the development process. So I'm going to talk about how my own like LLM orchestration framework does stuff. It's a pretty minimal framework. There's a handful of files, and that handful of files can do huge tasks as long as the planning is sufficient. And right now, I'm pretty sure the planning is sufficient. These are actually relatively small changes compared to things I've done in the past. It can run for hours and hours just going through this implementation plan. Not this one, but implementation plans in the format that I've created. It can just go for hours and complete the whole thing autonomously. So that's what I'm going to kick off tomorrow. And then because that process is going to be way less interactive, I'm going to kick that off and it's going to start going. And then I'll cover how that whole process works. And we'll go through and look at what it's actually doing. And I'll sort of demonstrate what it's doing and how that matches the documents that I have that sort of tell it how to do this development process. And then if it's not complete by the time we get through that, I'm going to start another project that is completely unrelated to this. Or, oh, you know what? I'll probably talk about how I implemented this feature in Claude Code. So I implemented in OpenCode first, but then OpenCode blocked the use of Claude subscriptions. So I can't use this effectively with Claude unless I pay a lot of money for the API token. You can pay via subscription, or you can pay like per use, per actual API call. Every time you call the API, you're charged for every input token and output token. That's very expensive compared to the subscription plans, but you can't use the subscription plans anymore with third-party tools like OpenCode. That was really discouraging because I'm mainly making this feature for me to actually use it to get real work done. So I went and I implemented this feature inside of Claude Code. So that will be either at the tail end of the next stream or in the stream following. I think that's all. All right, and the stream.